Hello, assalamu alaikum.
जी वालेकुम सलाम सर खैरियत है
Okay,
सर
so how are you?
आई एम फाइन सर आप हाउ आर यू सर
Alhamdulillah, I'm fine. Thank you.
सर योर लैपटॉप बिकम ओके फाइन नाउ
Okay, so now okay. Okay.
यस
Okay, so we will start today's class. So I simply start to the recording.
यस
Okay, so now can you see my screen?
यस आई कैन सी योर स्क्रीन
Okay, so we will start our today's class. So hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis. And today is our third day, and we also try to complete all of the course content. So within the 7 days, so this is our full course content.
यस
So today is our third day, and this third day course content will be that I will try to discuss about that how you can easily filtering and displaying the satellite image. So mainly in this time I will try to show you the Sentinel-2 satellite image, how you can easily filtering and displaying the Sentinel-2 satellite imagery, and then how you can easily monitor the NDWI using this satellite imagery. And then also try to discuss about that how can easily make the time series chart. So different types of time series chart. If you want, you can get the time series chart for every month interval time series chart, or every year time series chart. You can also get the 8-day interval time series chart, or different types of time series chart we can easily get from the Google Earth Engine platform. And all of the indices, not only for the NDVI or NDWI. If you want, you can any data set, suppose Modis Sonokawa data set or any other data set, we can easily get the time series chart for the different time period.
यस
And then I also try to discuss about the how can easily export any shape file. So how can easily export any shape file? It can be river shape file, lake shape file, or any other shape file. How can easily export from the Google Earth Engine platform. And then also try to discuss, just a minute. Okay, then try to discuss about the calculating any indices from satellite images. Suppose you can get the satellite image, it can be Landsat or Sentinel. Then you can calculating the indices. Okay, any indices, it can be NDVI, NDWI, or other indices. How you can easily calculating with the satellite images. We also try to discuss about that. Then how to add the gradient legend. So we also try to show you that how can easily add the legend on your map. Basically, legend is a two type: gradient legend and classified legend. So how can easily add the gradient legend? We also try to discuss about that. And then we also try to show you that how can easily work with the land surface temperature monitoring. So mainly we can develop the model using the Landsat imagery. How can easily get the land surface temperature monitoring using the Landsat. As well as I also try to show you the Modis. So basically Modis is the ready-made data. And then we can also use here the Landsat data, Landsat satellite imagery. How we can easily get the Landsat satellite imagery and get the LST map, okay, or LST land surface temperature monitoring, and also get the time series chart of the land surface temperature monitoring. We also try to discuss about that. And then we also try to discuss about that NDWI calculated from the Modis and Landsat data. So basically this data set is the ready-made data set, so that's why we don't need to add any equation or anything, so we don't need to add. But when you want to work with the suppose land surface temperature using the Landsat imagery, then you also need to add here the some model or some algorithm you need to follow when you want to work with the Landsat image for the monitoring the land surface temperature monitoring using the Landsat imagery. Then we also need to add here the some model or algorithm, then we can get the result. but which data is already available in Google Earth Engine platform, then we don't need to apply any model or anything because this dataset already ready made. Okay, then we can simply work with the dataset and can get the result. So let's go. So first of all, when you want to work with the filtering and visualizing the satellite images, so this is the basic concept. Previous class I also tried to discuss about the Landsat imagery, how you can easily filter the Landsat imagery, and in this time I also try to show you the Sentinel. And both of satellite imagery, when you want to filter, the basic thing is the same. So first of all, you need to filter the Sentinel-2 satellite imagery according to your region of interest. So according of region of interest, this is your ROI or your boundary shapefile. Suppose you want to need the satellite imagery for the Dhaka city boundary. So first of all, you need to import your shapefile of Dhaka city. So this is the one factor for filtering. Suppose I want to need the satellite imagery for the Dhaka city. I simply import my boundary of Dhaka city. Then I will move to the filtering the image properties. Okay. Suppose I want to need the Sentinel-2 satellite imagery. It cannot be more than 1% cloud cover. So this is my image metadata. I want to filter also image metadata or image properties. So this is my another factor. And third factor is that I want to need the image for the specific time period. Suppose I need the image for the year of 2017, or I want to need the satellite image for the any dry season or wet season. Okay, so you can also filter according to this image, according to the three factor. So when you want to filter the Landsat or Sentinel, both image, we also apply the three factor. Then we can filter our image, and then we can easily work with the different types of remote sensing work. So in this time, I also try to show you that for the Sentinel-2 satellite imagery. For this, I just simply open my code editor. Okay, so I simply open my code editor, then try to work with this. Okay, so I just simply open my code editor from my new browser. Okay, so I open a new code editor. So in this time, I want to work with my satellite image for Sentinel. Okay, so I simply browse the data catalog Sentinel. I simply click to the browse data catalog and then find out the Sentinel-2 satellite imagery. I think some networking issue in here. Just a minute.
No problem. It came.
Okay, so then I simply just go to the Sentinel. Just click on the Sentinel. So now I can get all of the image collection of the Sentinel-1, Sentinel-2, also you can Sentinel-3, Sentinel-5. Okay, I want to work with the Sentinel-2 satellite imagery. So I simply click on the Sentinel-2 satellite imagery, and then here you can see surface reflectance and top of atmospheric. So I want to work with the top of atmospheric image. So I simply click here. So here you can see a lot of information about the dataset availability rate. You can get the dataset between this time period, and also you can see dataset provider. So dataset provider is that European Union, ES, Copernicus, and you can get all of the things about the dataset. So first of all, I just simply copy this Earth Engine snippet from here. I just simply copy and then just simply open in my code editor. So I simply copy and just paste in my code editor in here. Then I put a variable name. Suppose I simply put the variable name is that, you can put any variable name. I simply put the variable name is the Sentinel-2. Okay, so you can see I simply call my image collection of Copernicus or Sentinel-2 satellite imagery and store it in this variable Sentinel-2. So in this time, suppose I want to need the satellite images for my region of Dhaka district. So I simply import my shapefile of Dhaka district in here. So here I already stored my shapefile of Dhaka district in my asset tab. So this is my area. I simply click to the in here. You can see now this shapefile is the stored in my code editor. So in this time I want
Yes.
to work with this data set. I simply put the name. Suppose this is my ROI. I simply put the name ROI. I want to need the satellite images for the region. You can see this region is that I simply show the layer of my shapefile. I simply use here the map.add layer, and then I simply call the ROI and click to the run. So now you can see I can get the result, but I did not see the center. So I simply use here the map.center object function. And then I simply call my object name is the ROI. And then I simply put here the suppose 10. So now you can say I can get the my area. So this is my region. I need the satellite images for this region. Suppose I need the satellite image for the region 2 period. I want to need the satellite images as a dry season, as well as I also need the satellite image for the wet season. So 2 time period I want to need the satellite images. So suppose I simply take a variable. I take the variable and give the variable name is that give the variable name is a suppose dry image. So I want to filter the image first time for the dry season and then also get the another for the wet season. So I simply call the Sentinel-2. This is my variable. I simply copy and paste here, and then I simply add here the filter bounds. Okay, filter bounds, so that this whole collection is intersecting with my shapefile, and my shapefile name is that you can see ROI.
ROI.
In this time I simply use here the another function. This is the suppose I have to need the image for the specific time period. Filter, I simply use here the filter date. Okay, suppose I want to need the data set for the year of 2021 20 for the dry season. Okay, so I simply put the time period for the dry season 2020 1st January. This is my start date of dry season, and in date I simply put here the 2020 April, suppose 30. Okay, so I simply put my dry season time period, and then I simply use here the in this time I simply use here the another function. It's called the filter metadata. Okay, then I simply put all of the argument, name, operator, and value, so I can get all of the things in the image properties. You can see, suppose I need the image which image is a less than 1% cloud pixel percent. So I simply copy the property name and then I simply paste here. Suppose I simply put the operator. So I simply put the operator is that I simply put the operator is the less than suppose 1. So now I want to check how many images is available for my region of Dhaka district between this time period for my region. How many images is available? Which image is the less than 1% cloud cover, 1% cloud pixel? I want to check it. So I simply print function, and then I simply call my dry image variable because it is stored in the dry image. Then simply paste here. Okay. Then I simply use the size function and click to the run. So now it will be showing me how many images is available for my region. For the dry season period, here I can get 31. And this 31 image is less than 1% cloud cover.
Okay.
Suppose in this time, I want to use the another function for instead of the filter metadata function. This function is also called the short function. So I simply commenting and use here the another function. It's called the short function. So if you want, you can also use the short function. Suppose I simply use here the short function, short, and then I simply call the cloud pixel percentage. Cloud pixel percentage. So this is my property. I want to short my image according to my. So that's why I simply paste here, and then I simply use a function. It's called the false. In this time I want to check how many images I want to get. You can see here I can get total 72 images for my region. In this time I want to just use here the sort function. So sort, when you want to use the sort, it will be sorting your images according to the one element. In this time this element is the cloud pixel percentage, and when I want to use the false function, it will be increasing, it will be decreasing the cloud pixel percentage. Okay, and according to the cloud pixel percentage sorting. So here I can get total 72 images. So in this time, suppose I want to make the mosaic. So mosaic means that I want to use the total 72 images, all of the images or my full collection 72 images, and make a one composite using the mosaic function. So I simply use here the mosaic. Suppose mosaic, and then it just clip with my shapefile. My shapefile is that, you can see, clip my shapefile is that, name is the RY. In this time you can see I just showing the result. I want to show the layer in my map, so I simply use here the map dot add layer, and then I simply call my object is that dry image. I simply copy the dry image and paste here, and then I simply click to the run. So now you can get the dry image for the Dhaka district between this time period. But you can say I did not see anything because I did not add the visualization parameter in this image. So in this time I simply click to the layer and go to the in here, and then I simply set the layer, my different band combination. I simply click to here. Okay, I simply set here the B4, B3 and B2. True color composite, also increase the 98% for better looking of the satellite image, and click to the apply. So now you can get the image, you can see, and this resolution is the very high 10-meter resolution only. So mainly when you want to work with this satellite images, you can get the better land use and land cover classification map, but this duration is very short. Okay, we can get the satellite image only for the 2015 to present time, like this. Okay, between this time period. Okay, you can 2015 to present time, but this resolution is the very high. Okay, but when you want to work with the long term LULC map or long term, then we also move to the Landsat image. Okay, because we can get the Landsat image from year of 1972. Okay, so we can get the lot of satellite images for the long period. But when you want to make the analysis with the short time period, from year of 2015 to present time, different types of land use, the land cover change, anything you want to give, then this image is the better, because this resolution is only for the 10-meter and Landsat resolution is the 30-meter. Okay, so in this time you can say I want to add the visualization parameter, and this image is also help for the identify the cropland. Okay, so because we can easily identify where the cropland is or not, we can easily identify. We can also zoom in and we can easily identify all of the feature on the surface. Okay, and we can easily work with the satellite images for the Sentinel-2 satellite imagery. So in this time you can say I can use here the visualization parameter, but this visualization is not import in my code editor. So I simply click on the import. You can see a new line code will be added here. I just simply copy the variable name and then paste after the object name. Okay, so now it will be okay. So in this time you can see I just simply take the image for the dry image. In this time I want to need this another image for the wet season image. So I want to need the image for the wet season image. Okay, so I can easily get the wet season image. Just I simply copy this code. From here, and then I simply change the date. I can simply change the date, then I can get the result. So I just simply copy this code from here. Just copy, and then I simply paste here. Okay, then in this time I simply change the variable name. Suppose I simply put the variable name is the wet image. So I simply put the variable name is the wet image, and then I also change the time period for the according to the time. For I simply put here the 1st June. So I simply use here the 06 1st June from October. Okay, so I simply use here the October, suppose 10. Okay, so mainly this is the rainy season or wet season. So in this time I want to simply change the time. Okay, so I simply change the time in here, and then you can see I simply copy this and simply paste here, and also put the layer name. Suppose I put the layer name is that this layer is the wet image.
there.
I simply put the wet image, and I also put the layer name another. Suppose this is the dry season image or dry image, and click to the run. So now you can see it's showing me the two layer in here. So you can see dry image and wet image. Okay, in this time here you can see the another problem is that when you want to work with the dry season image, here you can find lot of cloud. Okay, you can see when I want to work with the wet season or rainy season, here I can get the cloud. You can see this is the cloud, this is the cloud. Okay, lot of cloud we can get in here. So in this time you can see this is the cloud. Okay, in Google Earth has some function. We can easily use the function and remove the cloud and haze from the satellite imagery, and we can get the clear condition of satellite imagery. So in this time I want to show our next class how you can easily remove the cloud from the satellite images. So in this time I want to take the two images for the dry season and wet season. You can see dry season there is a nothing cloud, there is a totally clear image. But when I open the wet season, rainy season satellite images, here I can get the cloud. Okay, so in this time I want to use the two satellite imagery for the dry season and wet season, and I want to make a NDWI map, and I want to find out when the period is the NDWI is the high and when the period is the NDWI low. So mainly we can easily understand that when I want to work with the NDWI using the wet season image, there I can get the lot of water pixel value for the rainy season. And when I want to work with the dry season image, then I did not find very less. Okay, so permanent water, without permanent water I did not get the any water body in the surface. But when I want to work with the wet season image, so here I can get the lot of water pixel value with okay. So in this time I want to apply here the NDWI method, and then I want to calculate it the NDWI and see what is the condition of the two period for NDWI or normalized difference water index. Okay, so my image is ready. So now I want to check here the NDWI.
Sir,
Yeah,
excuse me.
yeah, any question?
Sir, it is it not possible that you today only you tell me about cloud cover removal, because every section will be completed, I think.
No, so actually cloud cover, when I want to work with the cloud cover, so that's why we also need to another class or another. So the cloud cover is the very vast topic. So we need to create the function, all of the marks, all of the things we want to need in here. So that's why
confusing.
yeah.
Okay,
So
okay, I got it.
yeah. So in this time I want to work with the NDWI. So NDWI is not hampered our cloud. Okay, because when you want to work with the land use and land cover, then this cloud is difficult for you. But when you want to work with the indices like this, then this cloud pixel is not very, because mainly when you want to work with the land use and land cover, then this cloud pixel value is the mixing with the build up area or barren land. Then we did not get the proper result. So that's why when you want to work with the land use and land cover, we always remove the cloud and get the clear image, then work with this. So in this time I want to show you the NDWI. Suppose I want to work with the NDWI. So first of all, I should know what is the formula for NDWI. NDWI formula is that, we can say that NDWI formula is the green band. So I simply write the formula: green band minus near infrared band divided by green band plus near infrared band. Okay, so this is our formula when I want to use this formula, I can easily get the NWI condition. Okay, so in this time I want to take this formula different way. So lot of process for applying this formula. I will show you the only for the one process. Then next topic I also try to show the all of the process, how you can easily make the equation and get the satellite images. So in this time I want to use here the built-in function. So Google Earth Engine has already defined a function. It's called the normalized difference function. So when you want to use the function, it automatically created the equation and get the result. So this built-in function is that. So I simply use the function. Suppose first of all I want to calculate the NDWI for the dry season. So I simply take a variable. Take a variable and give the variable name is the NDWI. Suppose dry. Okay. Then I simply call my dry image. Okay. You can see my dry image is stored in a variable dry image. I simply copy this variable name and paste here. In this time I simply use a function. This function called the normalized difference.
Sir.
Normalized.
Sir.
Yeah, ask me.
Sir, a small, sorry to disturb you, sir.
Yeah.
A small question, sir.
Yeah.
Sir, when displaying Sentinel data in your Dhaka city, it is only like one image is there or two images is there. If two images come,
your voice is very low. I did not hear you.
If two images come in our boundary,
yeah.
If two images come in our boundary of a study area, then can we visualize or work with the Sentinel data?
Yeah, we can work with this.
So, sir, please also consider it and show me in with that also, sir. Visualization of in that section, visualization of data. If two images come, like if you work in Midnapur, what happened in two images needed. Sometimes, okay, sometimes if you want to work in for West Bengal, then whole 5-6 satellite images needed. So I want to know how to use all satellite images and at one time.
Okay. So mainly in this time you can see here I use the mosaic function. Here I can get total 72 satellite imagery. I want to use here the mosaic. So mosaic is that take all of the images and get the one collection and make a one collection. And a previous class you can also see when I want to work with the median function or mean function. So this is the different types of process. When you want to reduce the image collection, it's the different type of process. So suppose you can see this image for the Dhaka district. So this Dhaka district is the combined total 72 tiles of satellite image. Total 72 satellite tiles. So in this time I want to get the total 72 satellite image tiles and make a one composite using the mosaic function.
Yes.
So if you want, suppose I want to need the median composite, I can simply use the median. Okay. Then you can see this area is the cover. Then we can easily work with this and simply use a clip function for clipping my region. So basically this image as a tiles. So here we can get the total 72 tiles. And this 72 tiles I want to reduce and make a one collection using the mosaic function. And then I can clip it. Then I can show my image only for my region of Dhaka district.
Sir, we can understand which date our image styles is of. Which date? Like in our study area, we write about the data information.
So it's different on your work. Suppose in this time I want to show the mosaic is the better for my region. So I simply use the mosaic. But previous class I also tried to show you the median. Then you can also use the median. Okay. So there is the nothing to the set of any constant. You need to use the mosaic. You need to use the median. You need to use the mean. There is a nothing constant. Okay. So you can check it. You can, when you want to work with your region, you can check it. Your mosaic collection is the better, or your median collection is the better, or your mean collection is the better. So in this time, our main goal is that we need to clear satellite imagery.
Yes.
Okay, we need to need a clear satellite imagery. Which satellite image is the better? So all time I need to work with the better satellite imagery for the better remote sensing work. And if you want, you can check the different method. Suppose you can see in this time I use here the short function, and if you want, you can also use the filter metadata, no problem. When I want to use the filter metadata, then I can get the less than 1 cloud pixel per sentence. Then I want to use the image, and I want to check if the image is the good. Then I work with this image. I want to check the short. I want to shorting according to my image properties, cloud pixel per sentence. I can check this image is the good. Then I also work with this. Okay. So our main goal is that clear satellite imagery. Sometimes you can see some satellite imagery has some gap filling region. Suppose you can see this is a satellite image and this region is the gap. Or you can see some satellite image has some line. Okay. Some satellite image has line or dot line. Okay. So then we can also use here the different process. If you want, you can check the mosaic function. If you want, you can use the median function for removing the problem and get the solution and get the clear condition of satellite imagery. Okay. So it's not fixed. Suppose we it's totally depend on our research work as well as also our area. Okay. So our main goal is that we need a clear image and perfect satellite image, and we can use here the different types of process: median, mosaic, mean, short, filter, metadata. Okay. And also you can see it's not only for the cloud pixel per sentence, and also you can there the lot of image properties. Okay. You can see cloud average assessment, lot of image properties is available here. So when you so different region has the different properties is the good. Suppose when you want to work with the polar region, then also you need to use here the another image properties. Okay. So different region has the different image properties is the better. So then we also work with this image properties and get the clear condition of satellite images. Okay. Okay, so I hope you can got the point. Yeah.
Sir, my final point is, sir, if we take like for example July month data, okay.
So July,
like
okay. So you can simply
1
put
July
here,
to 30 July.
So you can simply change the data in here, no problem.
No. You listen first. July month data 1 July to 30 July, and 2 ties are coming in that period. 2 ties. Okay. How I know this tile is of 5 July and this tile of 10 July? How I understand? How I can get information?
Okay, so you can simply change the filter date function. So you can simply put your according to time period. So in this time, I want to get the satellite images between this time period. Suppose you want to need for the only for the 1 month, only for the month of July, then you can simply use here the July or 06.
Yes.
Then you can get the only for the satellite image for the July, and you can check how many images available for your July month of July. You can get the some image. Then you can reduce this image collection according to the filter metadata, short function, mosaic function, median function, mean function. Okay. So every month, sometime you can see this region is not covered your only for the 1 month image. Suppose this month is not capture this satellite image, then you also need to increasing the month and then check it. Okay. Sometimes you can check it the 1% cloud pixel is not available for your region. Then you also need to increase the value for the 2%, 5%. Then check how many images is available in your area. Then you work with this.
Step by step.
Step by step, yeah. So
sir,
you want to
sir, one more thing. Like as I'm working for the Srinagar city, Kashmir Valley, then there are snow cover. Okay. Is there any function for this specific region to remove snow cover?
Yeah. Snow cover, we can also remove the snow cover. So when I want, suppose you can see, I want to show you the data set. Suppose.
Yes, surely. Yes, sir.
I simply go to the bands. So you can see mainly in this time, this is the QS60 band. So this band is the working for the cloud marks. You can see cloud marks. Okay. So also you can see this image has the bit 10 and bit 11. So bit 10 is the cloud and this is the Cirrus cloud. And I hope it's available only for the Landsat image. So I simply go to the Landsat. So Landsat image has also bit some the Sono index or shadow index, shadow. Okay. So you can easily remove the Sono and shadow. Just a minute.
Top of atmosphere.
You can see cloud shadow. You can also sono. You can see sono. Okay. So you can see this image has the bit 0 fill, then cloud, then you can see the another bit is the water. Also you can see the sono. Okay. So it has also some signal 0. 0 means that sono Orions confidence is not high, and 1 is that high confidence sono cover. Okay. So we can also remove the sono from our satellite images. We can easily remove the cloud shadow. All of the things we can easily remove. So you can see a lot of bit cirrus confidence. Okay. So when I want to work with the CloudMux function, then I hope you can easily work with that. How you can easily remove the sono or all of the details, cloud shadow. Okay. Then you can easily understand all of the things. Okay.
Okay,
so
sir.
it's possible.
Okay, sir.
Okay.
Thank you, sir.
Okay, so in this time you can see I want to work with this in here, so I simply call my dry image. So this is my dry image. I simply call, and then I use here the normalized difference function. So this is the totally built-in function. This function is already exist in here. So when I want to use the function, it automatically calculated this equation, and this equation has the two band. So I simply make a list and put here the band. Suppose this band is that B3 is the green band and B8 is the near infrared band. So I simply do this. So now my NDWI for the dry season is stored in here. So I simply copy. I just simply copy and then I simply paste here. Okay. And I put the variable name, suppose NDWI for the weight.
Okay.
And then I simply call the weight image. So you can see weight image. I simply copy the variable name and simply paste here. So now it also okay. So you can see I calculated the NDWI for the dry image, NDWI for the weight image. So now I want to show the result on my map. So I simply use here the map.add layer. Suppose I want to show the NDWI dry season. I simply copy and paste here. And then I want to add here the visualization parameter. So I want to make a list dictionary in here and start the mean value. Mean will be start from the -1, and I put the max value, suppose 0.5, and also add here the color plated. So I simply use here the plated function and make a list of color. So I want to show the color is that, suppose red. Then increasing the rate, I want to use here the YOLO, and then also use here the suppose green, and also use here the suppose blue, and then also put the layer name. Suppose this is the layer name is that NDWI, suppose dry. So in this time I simply copy this line and then I simply paste here, and then I simply copy this and paste here, and then I simply put the name is suppose NDWI weight and click the run. So now you can see our NDWI for the wet season, dry season. Okay, so what I wrong?
So, I think MAZ is correct. Maximum MAX or MAZ.
Okay, so sorry. So this is the MAX. Okay. Just a minute. So this is my object name. I simply use here the curly bracket start and curly bracket int. Okay.
Yes.
So then I simply put here the mean max value. Then use here the plated function PALE. Okay. So then use here the.
Sir, here dry capital dry DRY.
It's not problem. Okay, just a minute.
Okay.
Okay. So just we need to the object name. Okay, then click on. You can check. So I simply use it the map dot add layer. I simply call the and then paste here and click the run. So dry image. So this is my image. So cannot add the null e object as a layer.
Acha. Yes, sir.
So in this time I simply use the dinner with precision. Okay. So I simply open my previous class code. Just a minute. I already saved the code. Then check it.
Sir, you just do for only one data set. You remove all these things. You do for only one data set. Like only one season.
Okay. So we make the mistake in here. You can see I want to define a list. Okay. Okay. So you make the list mistake in here. So this mistake is
What?
that okay, I need to use here the this sign, then I simply put here the band B3 and B8. Okay. But first time I use here the square bracket, then put here the parenthesis. So that's why it make the problem. So now it okay. So now I simply just show the result. So I simply use here the
Comma was
dot
missing,
at-
sir. What you are telling? What was missing?
yeah. So first time I simply use here the square bracket and then put here the parenthesis. But in this time I want to
Okay.
use here then use it. Okay. So I simply copy and paste it. So now how it will be working. So just a minute, I take a phone, then continue. Just a minute. So now you can see it will be work. So I simply set here the visualization in this time. So I simply use here the curly bracket start and put here the mean. It will be start from the -1 and also use here the max 0.5. Okay, and also use here the color plated. I make a list of color plated. So I simply use here the color plated list is that like suppose red. Then also use here the green. So I simply use the red, then use here the yellow, then use here the suppose another color is that green, and put here the another color is that blue, and put the layer name is that try NDWI. I simply copy and then paste here, and then simply call this NDWI weight and paste here and change the layer name. Suppose this layer name is that weight NDWI.
Okay.
And then click to the run. In this time you can see now it will be work and we can get the another 2 layer for the NDWI. You can see it will be loaded.
Okay.
So this is the NDWI for the dry season. I also loaded the NDWI wet season. So mainly you can see when I want to work with the NWI wet season, here I can get the lot of water pixel value. Okay, and you can see this is the dry season and this is the wet season. Okay, you can see this is the wet season condition and this is the dry season condition. So we can easily export this map as a TIFF format, and we can easily make the map layout in ArcMap software or QGIS software, and you can see. Okay, so mainly rainy season we can easily identify the lot of cloud pixel for the water on the surface. Okay, so you can see this is the condition of the water pixel value for that between the dry season and wet season for the Dhaka district. Okay, so we can easily export this map and work with the ArcMap software. So in this time if you have any question you can ask me any question about this. And this is the same process.
No,
when you want to work with the NDVI, So you can just put here the NDVI band. NDVI band is the red band and near infrared band. Just put this, then you can get the result for the
NDVI you have
NDVI.
told. Yes, sir. So, I just want to know that we don't put a formula as we do formula in Erdas. We don't
Yeah.
need to do formula in Google Earth Engine, sir.
Yeah, so you can just put the formula when you want to work with the NDVI. And in this time, I use at the built-in function, normalized difference. This is the built-in function.
Okay.
So in this time, and later I also try to show you that how you can easily use the formula, directly formula. Because you can see in this time, I simply open this built-in function in the docs tab. Here you can see the normalized difference. So mainly this is the built-in function. It computes the normalized difference between the two band. Okay, and this normalized difference is computed as the first band minus second band divided by first band plus second band. Okay, so in this time I just simply use here the first band is the B3 and B8. So it will be calculated the B3 minus B8 divided by B3 plus B8. Then I can get the result of NDVI. But when you want to work with the equation, we also try to show you the later how you can easily work with the equation. Okay, using the satellite images, then you can easily understand all of the equation and put your equation, you can get the result. It can be EVI equation, NDVI equation, or VCI equation, TCI equation. All of the equation we can easily put in my algorithm, and then we can get the result. Okay.
Sir, I want to say that these equations are already saved in the memory of Google Earth Engine.
Actually, this equation is a totally remote sensing classes. Suppose when you work with the NDVI, so NDVI is mainly work for the identify the vegetation, and we can easily use here the near infrared band and red band for identify the vegetation. Suppose they're already set up that a lot of equation, so you can also show the some journal paper, any indices which you want to need, you can go to this and can get the different types of equation or indices equation.
Sir, in this NDWI, can I download the prepared NDWI in like, can we download the data?
Yeah, you can download the data. So I also try to show you that, so how you can easily download the data, all of the things, how you can easily export the CSV file format, all of the things we will try to complete. Okay, no problem.
Okay.
Okay, so in this time,
want to know how to yes. Okay. No problem.
Okay, so in this time you can see I want to just export the satellite images as a TIFF format, and I can simply open the ArcMap or QGIS software for making the map layout or other things for the NDWI map. Okay, and this is the process. You can simply change the band value, which band you want to need. You can get the result very quickly and efficiently. So when you want to export the map, we use